Hi everyone, we are going to talk about classifying polynomials today. So the first thing we have to think about is what makes an expression a polynomial in the first place? How does it fit into that category? So on the right side, you see some examples and some non-examples. So the ones under examples are considered polynomial expressions, and the expressions at the bottom are not. So let's look at the things that polynomials have that the non-examples do not have. So if you look at each variable has an exponent that is positive and also a whole number. So we see an x to the power of 3 and a z to the power of 5. Those are both whole numbers and positive. Down here we have a single x, which means it has a hidden exponent of 1. And here we have a 2 exponent, again, both positive whole numbers. In the third example, we have a variable in the numerator, and it has a positive exponent, that hidden 1. All of those situations are allowed for a polynomial expression. We are looking for positive whole number exponents on our variables. Under the non-examples, there are some things that don't fit into this category. So the first thing to look at is a variable under a square root. So we do not want any variables under a square root or a cube root or any other kind of root in our polynomial expression. So as soon as we see a variable under the square root, we do not have a polynomial. Notice in the example above, I did have a square root, but it wasn't a variable under that square root. It was just a number, and that is okay. It's having a variable under the square root that we would like to avoid. The next example has a negative exponent on the variable, and we do not want any negative exponents for our variables. So that is what discludes the second example from being a polynomial. In the third example, we have a variable in the denominator. We have a variable in the bottom of our fraction. We also do not want that. So we do not want any variables under square roots or any other roots. We do not want any negative exponents, and we do not want any variables in the denominator. So once we know, that our expression is a polynomial, we have some other specific ways to describe that polynomial. The first way is by degree. So in that case, we are going to look for the largest exponent in our expression. And based on that largest exponent, we are going to name it with a different name. So the first exponent that we can't really look for because it's missing is an exponent of 0, which really means that I don't have a variable at all. So in this first category, it's kind of a strange category, but we have an expression with no variables whatsoever. That is considered a constant expression, just a number. The next variable we might look for is a 1. Now, a lot of times a 1 exponent is not written. X to the first power is the same thing as just plain old x. So sometimes when we have a exponent of 1, it's hidden. So you'll see in this example, we don't actually see that exponent of 1. We're just supposed to know that there is a hidden exponent of 1. In that case, we call our polynomial a linear polynomial. The next category would be if our largest exponent is a 2. So in this example, we see this x over here that is raised to the power of 2. So we're looking for our largest exponent. That would be considered a quadratic polynomial. So something with an exponent of 2 is quadratic. That I'm sure you've seen before. The next would be if our largest exponent is a 3. So notice this last term here has an exponent of a 3. It's the biggest exponent that I see, so that's what I will use. And that would be called a cubic polynomial. So then I just wanted to do a couple examples that were a little bit different. So you'll notice that in this next example, I have actually 2 variables, x and y. And so what I'm looking for is the term where the exponents would add up to the biggest number. So in this term here, I have an exponent of 2 and 2. So together that would add up to 4. So we have this little term here that is considered to have an exponent overall of 4. That is bigger than this exponent over here of a 2. So we are going to go with the 4 exponent. That would be considered a quartic. expression, a quartic polynomial. The next one, again, I wanted to do one that was a little bit different. This also has a term with an x and a y. The x has an exponent of 4, and the y has one of those hidden 1 exponents. So together, the exponents would add to 5. So this would be considered a quintic polynomial, or a degree of 5. If you get past 5, if you have an exponent of 6 or 7, or an exponents that add to 6 or 7, then we don't have a special name. We will just call it a 6th degree, or a 7th degree, or an 8th degree, or 9th degree, etc. So that is one way to name a polynomial, is by its degree, or by its largest exponent. The other way to name a polynomial is by the number of terms that it has. So terms are separated by either a plus or a minus sign. So I've underlined separate terms here. So this first example only has one term, and that would be called a monomial. Mono is the root for 1. So that has one term. This second example down here has 2 separate terms. If you see the plus sign here, those separate the 2 separate terms, and that would be called a binomial, bi as the root for 2. In the next example, we see 3 separate terms. Notice they're separated by this plus sign here and the minus sign. So that is 3 separate terms. That is called a trinomial. Again, that root is tri for 3. And then the last example is basically if we have 4 or more terms. So this one has 4 separate terms separated by plus signs. If you have 4 terms or 5 terms or 6 terms, etc., we'll just call it a polynomial. Poly is the root for many. So this is just many terms. So once you hit a 4 or above, we just kind of say polynomial. All right, so let's look at some a few more vocabulary words, and then we'll try a couple. So first of all, I've given you an expression, a polynomial expression. I'm pretty sure it's a polynomial, but let's check. We have an exponent here that is both positive and a whole number. And we have an exponent here that is positive and a whole number. And our variable is in the numerator, not in the denominator, not in the bottom. So this is okay for a polynomial. So if we wanted to write the polynomial in what is called standard form, we're going to rearrange the terms in order from largest to smallest exponent. So I'm going to take this last term here, this negative x to the third over 5, and I'm actually going to write that first because it has the largest exponent. The 4x squared will stay in the middle. That has the next largest exponent. And the number without a variable at all comes last. When we write this in standard form, we can talk about the leading term. So that is the very first term. So in our case, the negative x to the third over 5. So that is our entire leading term. It includes the variable. We can also talk about the leading coefficient, which is just the number in front of the variable. Just the number in front of the variable, not the variable itself. So this is a negative 1/5 for our leading coefficient. The constant term is the term that has no variable with it at all. So in our case, the 2 would be the constant term. Okay, so let's test our memory about some of these terms. So if we look at this expression up here, is it a polynomial, and how do we know? So you can pause the video so you can think about whether this is a polynomial or not and how you might know that. When you're ready for an answer, you can unpause the video. Okay, so we know that this is a polynomial, yes, because all the variables have positive exponents. They are also whole number exponents, a whole number positive exponent, and we have no variables underneath a square root. Okay, what about the type of polynomial with the number of terms, the constant term, the leading term, and the leading coefficient? So again, take a second and pause the video and see if you can fill in all of the blanks here. Okay, So this expression will represent a cubic polynomial. If we look at the exponents, the largest exponent is a 3. Therefore, we would call this a cubic polynomial. Now, there are also 3 separate terms. There's this one, there's the middle term, and there's the last term. 3 terms would make this a trinomial. The constant term is 1. That is the number that doesn't have a variable at all. The leading term is not necessarily the very first term. It's the first term if we rewrote this in standard form. So if we were to rewrite this in standard form, the negative 1/7 x to the third power would come first because it is the highest exponent. So that is considered the leading term. The leading coefficient is the number itself without the variable part. So that is just negative 1/7. Thank you for listening.